Welcome back to the Deep Dive. Today, we are completely flipping the script. We are. Usually, we take a stack of articles, maybe a new business book or a research paper, and we unpack it for you.
Right. We summarize, we synthesize.
Exactly. We
Yeah.
give you the takeaways. But
Sure.
today, we are going strictly interactive. We are running a simulation.
That's right. And it's something we talk a lot about on this show, technical leadership, architectural patterns, that kind of thing.
All the buzzwords.
All the buzzwords. And it is very easy to sound smart when you are, reading a blog post or summarizing a textbook. But the real test of that knowledge, the crucible where it actually matters, it isn't in a book.
No.
It is in the interview room. Specifically, the high-pressure environment of a senior technical interview.
And the stakes here are incredibly high. We're not talking about a junior developer role where you just, need to know how to write a loop.
Not at all.
We have a stack of source material today that outlines a very specific, very high-level role, a contract ecom VIAX lead based in London. We're talking about a day rate that would make your eyes water, but the expectations absolutely match. We have the job description, we have the technical requirements, which are, frankly, absolute beasts.
I looked through them, they're intense.
And we also have a master interview guide that's designed to test a principal or a staff-level engineer.
And reading through all of that, it is just abundantly clear this isn't a do you know your syntax kind of interview.
No.
They aren't going to ask you to reverse a linked list on a whiteboard or solve a Sudoku puzzle in code. This is all about judgment.
It's about trade-offs.
Exactly. Trade-offs, commercial awareness, and honestly, risk management.
So to get the most out of this, we figured we'd role play.
Let's do it.
I am going to assume the persona of the interviewer. So I'm going to be the hiring manager. I am experienced. I'm a little aggressive. And I have zero patience for fluff.
Okay.
I have a budget to burn and a Q4 deadline that is, frankly, terrifying. I want to know if you can actually build this system or if you're just good at talking about it.
And I naturally will step into the role of the candidate.
Right.
I'll be playing the part of a seasoned practitioner with, say, over 10 years of full stack experience, Node.js, React, AWS, the whole stack.
Perfect.
And my goal is to demonstrate not just that I know the code, but that I can lead the strategy and manage the chaos.
Manage the chaos. I love that.
Yeah.
So for you listening right now, imagine you are sitting in the third chair of this panel.
You're a fly on the wall.
Exactly. A fly on the wall for a high-stakes London tech interview.
Oh.
We're going to decode exactly what it takes to land a role like this. We might pause occasionally to explain why an answer was good or bad, but mostly, we're just going to let the sparks fly. Are you ready to get grilled?
I am ready. Let's do it.
All right. I'm shifting gears. I'm entering the room.
Okay.
Tone shifts to professional, slightly abrupt, authoritative interviewer persona. Good morning. Thanks for coming in. Grab a seat.
Shifting tone to confident, professional candidate persona. Good morning. Thanks for having me.
Look, I have reviewed your CV, and on paper, the 10 years of full-stack experience looks relevant. You've got the keywords.
Okay.
But we are moving fast here. We have a deadline that isn't moving, and stakeholders breathing down my neck. We need someone who can hit the ground running on day one.
Understood.
So skip the life story. I don't need to know where you went to university. Give me a concise introduction, focusing specifically on your recent e-commerce leadership. Why are you the right lead for this VIAX migration?
Of course. In the last 4 years, I've specialized exclusively in replatforming legacy monoliths into composable, headless commerce architectures.
Okay.
Most recently, I led a team of 12 engineers for a high-volume UK retailer, where we migrated their entire legacy platform to a Node.js and React stack on AWS.
Right.
My focus is on the intersection of, let's call it, architectural cleanliness and commercial speed.
Right.
I don't just write code. I design systems that allow the business to ship features faster. I've been deep in GraphQL Federation and event-driven architectures using Kafka, which I see are core to your requirements here.
They are.
So essentially, I build platforms that do not fall over on Black Friday, and I build teams that can maintain them after I leave.
Interviewer persona. Okay, don't fall over on Black Friday is a bold claim. Everyone says that until the traffic spikes.
It is.
We will test that in a bit. But first, I want to ask about the nature of this engagement. This is a contract role. It's London-based. It is high intensity. Why are you looking for a contract role specifically? Why not a permanent staff position where you can own the roadmap for 5 years? I need someone committed, not a mercenary, who is going to jump ship for a higher rate in 6 months.
That's a fair question, and I appreciate the candor.
Good.
But I would argue that for a migration of this magnitude moving to Viax, going headless and mercenary is exactly what you need, if by mercenary you mean a tactical injection of expertise.
Go on.
The value proposition I bring as a contractor is speed to value. In a permanent role, you spend the first 3 months learning the politics, the HR structures, the 5-year vision.
Right, the onboarding.
As a contractor, I view myself as a specialist surgeon. You have a specific problem. A transition to a headless architecture that is complex and likely stalling or needs acceleration.
It needs acceleration.
And I've done this specific surgery 3 times before. I come in, I know where the pitfalls are, I set the patterns, and I upskill your permanent team to take over.
And London.
I thrive in the London market specifically because the pace here demands that kind of adaptability. You don't pay me for my potential 5 years from now. You pay me for my immediate impact on the P&L this quarter.
Immediate impact. I like the sound of that, but let's see if you have the architecture chops to back it up.
Let's move.
Let's move to phase 2. Architecture. We are building a large-scale headless solution. We are moving away from our old monolith. We're using React on the front end, Node.js on the back end. Simple enough on paper.
It seems so.
But I see teams mess this up constantly. They build a distributed monolith that is harder to manage than the old system.
The worst of both worlds.
Exactly. So how do you split the responsibilities? Where do you draw the line between what React does and what Node does?
This is probably the most common failure mode in headless projects. The line has to be absolute.
Okay.
React, in a headless setup, must be strictly responsible for the experience layer. It manages the UI state, the interactivity, the animations, the presentation logic. It should be as dumb as possible regarding business logic.
The how?
It shouldn't know how to calculate tax, it shouldn't know how to validate stock levels, and it certainly shouldn't be applying discount rules. All of that is business logic.
So where does that logic go?
It goes into the Node.js layer, which acts as the BFF, the backend for front-end. This is the orchestration layer.
Or BFF.
Yes. It aggregates data from your various downstream microservices, pricing, inventory, catalog, CMS, and it sanitizes it for the front-end.
Why is that step so important?
Because you do not want your React app making 5 different API calls to 5 different services just to render one product page. That is a performance killer on mobile networks.
The round-trip latency?
Exactly. The round-trip latency will destroy your user experience. Node sits in the middle, in your private network. It makes those 5 calls with a very low latency, stitches them together, removes all the data the front end doesn't need, and sends one clean, lightweight JSON payload to React.
So, a simple rule.
A very simple rule. React is for showing, Node is for knowing.
Okay, let's pause on stitching them together. We use GraphQL. A lot of candidates tell me they love GraphQL because it is flexible. But in a team of 20 engineers, flexible usually means chaos. I have one team working on checkout, another on catalog, another on search. How do you manage GraphQL schema at scale without it becoming a spaghetti mess of conflicting types?
You're absolutely right. Flexible without governance is a disaster.
So what's the governance?
The solution here isn't a single monolithic schema file that everyone fights over. The solution is federation.
Explain that.
In a large e-commerce setup, you shouldn't have one giant GraphQL server. You want a gateway. You break your domain down into subgraphs.
So domain-driven.
Precisely. The checkout team owns the checkout subgraph. The catalog team owns the catalog subgraph. Each service exposes its own small, clean, autonomous GraphQL schema.
And how does the front end see it? Still just one endpoint.
Yes. The gateway uses federation to stitch these into a single supergraph that the front end consumes. To the front end developer, it looks like one API.
But it's not.
But on the back end, the ownership is decoupled. And this solves 2 huge things. 1, ownership. Teams don't step on each other's toes. I can deploy the catalog subgraph without touching the checkout subgraph.
And the second?
2, performance. You can tune the caching at the subgraph level. If the pricing service is slow because it's calculating real-time tax, it doesn't necessarily block the content service if you structure your queries right.
You touched on performance. One of the biggest issues I see with GraphQL is the N+1 problem fetching data in a loop.
Ah, yes.
Yeah.
Classic.
I have seen junior devs take down a database because they requested a list of products and then for each product requested the author details or inventory details separately. How do you stop a junior engineer from writing a query that accidentally databases our database?
Data loaders are the first line of defense. You have to enforce the use of data loaders in your resolvers to batch requests.
What's the difference in practice?
Here is the difference. Without a data loader, if I ask for 50 products, the server hits the database 50 times for the related data. It's a loop.
Right.
With a data loader, the server is smarter. It waits a few milliseconds. Just a single tick of the event loop collects all 50 IDs from those requests and sends one query. Give me details for IDs 1 through 50.
So it turns 50 queries into one.
Exactly. It's a massive performance gain.
Is that enough, though?
No. That protects the database, but it doesn't protect the GraphQL server itself from parsing massive, deeply nested queries.
So what's the next layer?
Beyond data loaders, we need query complexity analysis at the gateway level. We configure the Apollo server, or whatever gateway we use, to assign a cost to every field.
A cost.
Yes. A simple field might cost 1 point. A related field that requires a database lookup might cost 10 points. We reject any query that goes more than, say, 4 levels deep or has a calculated complexity score over 1,000.
But you kill it before it runs.
You stop the bad query before it ever hits the resolvers.
Yeah.
It's about building architectural guardrails, not just trusting people to write good code.
Good. Guardrails. I like that. Let's move down the stack. We use AWS Lambda. We are big on serverless, but we also have complex workflows. A return process, for example. It involves updating inventory, refunding payment, notifying the warehouse, and emailing the customer. If you try to chain Lambdas together for that, Lambda A calls Lambda B calls Lambda C, it's a nightmare to debug. It's invisible.
It's the Lambda pinball anti-pattern.
Exactly. So how do you handle that workflow orchestration?
You never chain Lambdas directly. That's the first rule. You lose track of where the data is, and if Lambda C fails, Lambda A has no idea.
So what do you use instead?
For the scenario you described, the returns process, that is a stateful workflow. I would use a tool like Conductor. Since your stack mentions Conductor, let's go there.
Okay.
Though AWS step functions is very similar in concept, Conductor allows you to define the workflow as a JSON definition, a state machine. It manages the state. It calls the update inventory Lambda. If that succeeds, it calls the refund payment Lambda.
And if refund payment fails, what happens then?
Crucially, if refund payment fails, Conductor knows, it sees the failure. It can then trigger a compensating transaction.
Compensating transaction, what's that?
It's a specific Lambda designed to undo the previous step, so it would trigger a Lambda to undo the inventory update. The Lambdas themselves remain stateless and single purpose. Conductor is the brain that remembers where we are in the process and what to do when things go wrong.
Okay, let me just jump in here. Breaking character host voice. I want to pause the simulation for just a second there.
Breaking character expert voice, sure.
Expert, you threw out a term there. Compensating transaction. For the listener who hasn't built a distributed system before, could you explain why we need that? Why can't we just roll back the database transaction like in the old days?
Well, great catch. And it's a really important concept. In the olden days, with a monolith, you had one big database.
Right, everything in one place.
Exactly. If something went wrong in the middle of a process, you just commanded the database to roll back, and it would magically undo everything that happened in that transaction.
The magic undo button.
The magic undo button. In a microservices world, that button doesn't exist. The inventory lives in one database, and the payments live in a completely different database, or maybe even a third-party API like Stripe.
Right. You can't roll back Stripe.
You cannot roll back Stripe. You cannot force their database to undo something. So you have to write a new transaction that does the opposite. If you took money, you have to write code to issue a refund. If you reserve stock, you have to write code to unreserve it.
So you're building the undo button yourself.
You're building the undo button yourself. That's a compensating transaction. It's much harder to build, but it's the only way to stay consistent in a distributed world.
That is a key insight. There's no magic anymore. Okay, switching back to interviewer persona, back to the interview.
Switching back to candidate persona.
Okay, candidate, I want to push you on a trade-off here.
Yeah.
You are talking about microservices, Lambdas, federation, Conductor, compensating transactions. This is extensive distributed complexity.
It is.
We have 10 million in revenue. Why not just stick to a monolith? Why are we over-engineering this? Why shouldn't I just fire the team and hire 3 guys to build a modular monolith in Laravel or Rails? Convince me I am not wasting money.
That is the multi-million-pound question, isn't it?
It is.
And frankly, for 10 millions in revenue, a modular monolith might be the right choice if your goal is just to maintain the status quo.
Our goal is growth.
Right. So if your roadmap involves scaling to 100 million or expanding to multiple regions with different compliance rules, or experimenting with different front-end channels like a mobile app, kiosks, or voice, the monolith becomes the bottleneck.
How so? Be specific.
The trade-off is this. A monolith gives you easy deployment and simple debugging at first, but it gives you high coupling. Everything is tangled together.
So a change in one place.
A change in one place breaks something else. If you want to change the checkout flow, you might break the user profile page because they share a database table. Microservices buy you deployment independent.
Deployment independent.
Yes. The checkout team can ship on Tuesday, and the catalog team can ship on Thursday. They don't need to coordinate a massive release night where everyone stays up until 2 a.m. praying nothing breaks.
So it's about team agility.
It's about team agility and business agility. As a lead, my job is to ensure we don't go to microservices too early. But given you're hiring for a Viax lead in London, it implies you're already hitting the limits of your current architecture.
We are.
You need the agility to swap out pieces like your search provider or your payment gateway without rewriting the whole platform. That is what composable architecture buys you. It buys you the ability to change your mind later without rebuilding from scratch.
Okay, good answer. It buys us agility, but it costs us complexity.
Always a trade-off.
Let's talk about that complexity in phase 3. Order orchestration. Walk me through the order-to-cash lifecycle. Customer hits buy. What happens? And do not just say, we save it to the database. I want the real operational flow.
Of course. Okay, let's trace the happy path first, then we can talk about where it breaks.
So good.
Step 1 is cart validation. First, we revalidate the cart. Are the items actually in stock right now? Have the prices changed since the user added them an hour ago? Step 2 is inventory reservation. This is critical. We place a temporary hold or reservation on the inventory. We don't deduct it yet, we just lock it so no one else can buy it.
Prevents overselling.
Exactly. Step 3 is a fraud check. We pass the payload to a fraud provider to get a risk score.
Okay.
Step 4 is payment authorization. We get a tokenized authorization from the payment gateway. We're not capturing the funds yet, just making sure the money is there.
An authorization, not a capture. Key difference.
Huge difference. Yeah. Step 5 is order creation. Only now, after all those checks, do we write the order placed record to our core database.
Yeah, man.
Step 6 is the orchestration kickoff. This triggers an event order created, which brings us to step 7, fulfillment. The warehouse system consumes that event, picks, packs, and ships.
And finally, the money.
Exactly. Step 8 is capture an invoice. Once the order is shipped, we capture the payment and email the invoice. That's the happy path.
That sounds lovely. Now break it. The payment provider times out, it hangs, but you have already reserved the inventory. What happens? Does that inventory sit there locked forever?
No, absolutely not. This is where resilience engineering comes in. If the payment gateway times out, we cannot leave that inventory locked.
So what do?
We need a timeout on the reservation itself, a time to live, or TTL. If the order isn't confirmed within, say, 10 minutes, the reservation expires automatically and the stock goes back into the available pool.
And you'd manage that where? Redis?
Redis is perfect for that. Keys with an expiry. For the payment specifically, if it times out, we implement a retry mechanism with exponential backoff.
So you try again.
We try again in 2 seconds, then 4, then 8. But, and this is the absolute key, we must ensure idempotency.
Define idempotency in this context. Why do I care?
You care because idempotency is the difference between charging a customer once and charging them 5 times because of bad Wi-Fi.
Right.
Idempotency means that if I make the same request multiple times, the result is the same as if I made it once.
How do you achieve that with the payment?
If I retry the charge customer call because of a network blip, I absolutely cannot charge them twice. The payment gateway usually provides an idempotency key. I generate a unique ID for this transaction, say order 123 payment.
And you send that with every call?
Every single retry. The gateway sees that ID and says, oh, I already processed order 123 payment. Here is the success message again. It doesn't run the charge a second time. Without idempotency keys, a retry loop is a guaranteed way to destroy customer trust.
Excellent. That brings us to phase 4, middleware and event-driven design. You mentioned the order create event, we use Kafka. Here is a debate I have with my architects constantly.
Yeah.
How do you design the topics? Do we have one massive topic called global events? Or do we have orders, payments, logistics, and what goes into the event payload?
Okay, first, please, never one massive topic. That is a nightmare for consumer scaling and for security.
Why?
Because every service that needs any event has to have access to all events. It's a security and a complexity nightmare. You want topics based on the domain entities, orders.lifecycle, inventory.updates, payments.status.
Okay, that makes sense. Now, the payload. What goes in the message?
So regarding what goes into the event, there are 2 main schools of thought. Event notification, where you just send the ID, versus event-carried state transfer, where you send the whole payload.
And you prefer?
For a high-performance system like this, I lean strongly toward event-carried state transfer. The order-created event should contain the critical data, order it, customer ID, items, total, the important stuff.
Why bloat the message? Why not just send the ID and let the other services call back for the details?
Because if I just send the ID, then every single consumer marketing, warehouse, analytics, loyalty has to immediately call the order service API to get the details.
Thundering herd.
A thundering herd, exactly. You've just created a massive read dependency on your order service. You have accidentally recreated the monolith just over the network. By putting the data in the event, the downstream systems can process it independently without hammering the source system.
But if you put the data in the event and the structure of that data changes, you break everything.
Yes.
If I change address from a string to an object, the warehouse system crashes. How do you prevent that?
That is why we use a schema registry. It's non-negotiable.
How does that work?
We define the schema for every event using Avro or protobuf strictly. If I need to change the address field, I create a new version of the schema. The schema registry enforces compatibility checks.
So it won't let you deploy a breaking change.
I literally cannot publish a change that breaks downstream consumers, like removing a mandatory field.
Yeah.
It forces me to make a backward compatible change. The consumers can then upgrade to the new schema version at their own pace. It's a contract, just like an API. It provides stability.
Okay, one last thing on Kafka. Exactly once delivery. My business team, they love this phrase. They want to know that every order is processed exactly once. Can you promise me that?
I can promise you I will try, but I will design for at least once.
Why not exactly once?
True, exactly once in a distributed system is incredibly expensive and, frankly, almost impossible to guarantee end-to-end. Kafka Stream supports it, but it adds latency and complexity.
So what's the reality?
The reality is network partitions happen, and acknowledgement will get lost. Kafka will think the message wasn't delivered, and it will deliver it again. So instead of fighting physics, we embrace at least once delivery and rely on the idempotency we discussed earlier.
So you build the consumer to be smart.
Exactly. My consumer needs to be smart enough to say, I have already seen order 123, I will ignore this duplicate message. That is a far more robust and realistic architecture than trying to force the network to be perfect.
Breaking character host voice. Okay, jumping in here. This concept of at least once versus exactly once is fascinating.
Character expert voice. It really is.
It sounds like the candidate is admitting defeat, but actually it feels like they're being realistic. Expert is this common. Do leaders really tell the business, I can't guarantee exactly once?
The best ones do, absolutely. If a candidate comes into an interview and tells you, yes, I can guarantee exactly once delivery 100% of the time, they are either lying or they don't understand distributed systems.
And what are the other?
One or the other. The lead mindset isn't about promising perfection. It is about building systems that survive imperfection. You assume duplicate messages will happen. You assume network calls will fail. You build your system to handle those things gracefully.
So it's about resilience, not perfection.
That's resilience.
Got it. Embracing the chaos. Switching back to interviewer persona. Okay, let's pivot. Phase 5. AI enablement.
Switching back to candidate persona.
Okay, the job spec explicitly says, should have used and enabled AI across design, development, and testing. I am tired of people telling me they use ChatGPT to write emails.
Mm-hmm.
I want to know how you embed AI into the SDLC, the software development lifecycle, to actually save me money or time. Don't give me the hype, give me the workflow.
Right. It's about moving from AI as a toy to AI as a teammate.
Exactly.
Here is how I've implemented it in my last role. First, development. We integrated GitHub Copilot, but we set very strict rules. It is not for copy-pasting logic you don't understand.
What's it for then?
We use it primarily for boilerplate reduction, generating the typed interfaces for GraphQL or the repetitive scaffolding for unit tests, things that are necessary but tedious. It speeds up the boring coding by about 30–40%.
Okay, that's a real number. What's next?
Second, testing. This is the high-value area for me. I have used AI agents to analyze our user stories from Jira and automatically generate the Gherkin syntax for Cucumber test cases.
What's the benefit of that?
It ensures that we are testing exactly what the product owner asked for. It removes the human translation error that often happens between the product team and the QA team.
Interesting. And the third area?
Third, observability. This is huge. We pipe our logs into a tool that uses machine learning to detect anomalies. Instead of setting a static threshold like, alert me if errors are greater than 5%, the AI learns the daily rhythm of our system.
So it knows what's normal.
It knows that traffic drops at 3 a.m., so a drop isn't an error. But if payment failures spike by just 1% on a Tuesday morning, which is unusual for a Tuesday, it flags it. It catches issues before a human would ever notice them on a dashboard.
What are the risks? If you let an AI write code or generate tests, what keeps us safe? I don't want a robot introducing a backdoor into our system.
A very real concern. There are two main risks: hallucinations and security.
Explain hallucinations.
The AI generates code that uses a library that doesn't exist, or worse, a library that has a known vulnerability. You cannot skip the security scam. We still run Snyk or SonarQube on every single pull request. The AI code gets scrutinized just as hard, if not harder, than human code.
And the second risk.
The lazy senior effect. Seniors get complacent. They stop reading the code closely because, oh, the AI wrote it, it must be fine. As a lead, I enforce that code review standards actually need to go up, not down. You have to review AI code with the assumption that it is confidently wrong.
Confidently wrong. I like that. That is a good bumper sticker.
It's true, though.
It is. Okay, let's do a rapid fire round. Phase 6, platform tooling. I'm going to throw out a tool name from our stack. You tell me why we use it and the one gotcha to watch out for.
Okay, let's do it.
First, Netlify.
Why? Instant CI/CD and deploy previews. The ability for a product manager to see a live, interactive URL of a feature branch before it merges is a game changer for feedback loops.
It stops arguments.
It stops the "it looks different on my screen" argument, yes.
Gotcha.
Serverless function timeouts. If you have a long-running API call in a Netlify function, it will time out after 10 seconds by default. You need to move any heavy lifting to background workers or a true Lambda function.
Okay. Noibu.
Why? Revenue protection. It tracks specific error classes that directly impact conversion. It doesn't just say JavaScript error. It tells you the add to cart button is broken specifically on iPhone 12 running iOS 14. It monetizes error log.
And the gotcha.
Noise. If you don't tune it properly, it will flag every random browser extension error. You need to curate the alerts to focus only on high-impact issues, or your team will get alert fatigue and start ignoring it.
Good point. Last one, Constructor.
Why? AI-first search. It's a different paradigm. It optimizes search results, not just on keywords, but on revenue. It shows the products that are most likely to sell, not just the ones that best match the word blue. It automates merchandising,
Kasha.
the cold start problem. It needs data to learn. When you launch a brand new product catalog, the AI takes time to optimize. You need to have manual merchandising, rules boosting certain products, burying others for day one, or the search results will look weird until it's gathered enough data.
Okay, you know the tools. Let's get to the hardest part. Phase 7, leadership and scenarios. You are the lead, but you are a contractor. You are a product manager who wants to ship a new, shiny checkout feature next week. You know the code base is spaghetti, and adding this feature will increase our technical debt to a critical level. How do you tell them no without getting fired?
I don't say no. I say yes, and here's the cost. If I just say no, the code is messy, the business just hears the engineers whining. It's not their language.
She translate it.
I translate it into risk. I say, we can ship this next week. However, because the checkout flow is currently fragile, adding this new feature on top increases the risk of a checkout outage during the upcoming sale by, say, 20%. Or we can spend 2 weeks refactoring first and then ship it safely with near zero risk.
And you let them choose.
I give the decision back to the business. If they choose to accept the risk, that is their prerogative as the P&L owner. But I have done my job by making the risk visible and quantifiable. Usually when you frame it as revenue risk, they find the time for the refactor.
Good approach. Now let's simulate a crisis. Scenario A. It is Black Friday, peak traffic, the site is down, 503 errors everywhere. You are the lead. What do you do in the first 5 minutes?
Okay, first 5 minutes. It's triage. Number 1, stop the bleeding.
How?
Can we roll back? If we just deployed new code in the last hour, revert it immediately. Don't try to fix forward under that kind of pressure. That's how small outages become big ones.
What if you can't roll back?
Then step 2 is shed load. Can we degrade the experience gracefully? Turn off the recommendation engine. Turn off the people also bought section. Turn off anything that's not critical to the core. Add to cart and checkout flow. It is better to have a dumb site that sells things than a smart site that is completely down.
And step 3.
Communication. I need to be on a bridge with the key stakeholders giving clear, calm updates. We are investigating X. We have taken action Y. Next update in 10 minutes. Panic is contagious. Calm is also contagious.
Okay, scenario B, Kafka lag. The order confirmation emails are delayed. Customers are calling support saying, I bought this 2 hours ago, where's my email? The engineering team says the consumer is lagging. How do you investigate and fix it?
Right. If the consumer group is lagging, it usually means the consumers can't process the messages fast enough.
So the immediate fix?
The immediate fix is to scale the consumers, add more instances of the email sender service, more workers to clear the backlog.
What's the catch?
The catch, and this gets a lot of people, is that you can only scale consumers up to the number of partitions you have in the Kafka topic. If you have 10 partitions and 10 consumers, you're at max capacity. Adding an 11th consumer does absolutely nothing. It will just sit there idle.
So if you're maxed out?
If we are maxed out on partitions, then we have a bigger problem. We might need to optimize the processing logic itself, make the email sending more async, or in a worst-case scenario, repartition the topic, which is a painful, disruptive operation. But the immediate tactical move is always check if we are maxed on consumers relative to partitions.
Okay, last one. Scenario C. An AI-generated feature, let's say a new customer service chatbot, starts hallucinating. It offers a customer a 90% discount code that doesn't exist. The customer's on social media and they're angry. What do you do?
Kill switch immediately.
That's it. That's step one. Every single AI feature in production must be wrapped in a feature flag. I flip the flag and launch Darkly or whatever tool we use, and the chatbot disappears from the UI instantly.
And the angry customer. We deal with the angry customer via customer support. Honoring the discount is a business decision, not mine, but we make it right. Then we do a post-mortem. Why did our guardrails fail?
Right.
We clearly need a system prompt layer that explicitly forbids the AI from generating discount codes. We update our test suite to include adversarial testing, actively trying to trick the bot into giving discounts before we even think about turning it back on.
Dropping the aggressive interviewer persona, returning to friendly host voice. Okay, stop. Whew, let's take a breath. That was intense.
Dropping candidate persona, returning to expert voice.
I felt my blood pressure rising just listening to the Black Friday scenario.
It was, but that is the reality of these roles, you know? It wasn't about define a variable in Node.js. It was about how do you save the business when things go wrong.
Exactly. And what stood out to me in that simulation, and what I hope stood out to you listening, is the shift in focus as you get more senior. When we started with the architecture, you noticed the candidate didn't just list technologies. They talked about orchestration.
Right. The lead role isn't about writing the most code. It is about defining the boundaries. The distinction he made between the experience layer, which was React, and the orchestration layer, the Node, BFF, and Conductor, that's critical.
If you get that wrong.
If you miss that, you build a mess. Also, notice the emphasis on failure. The happy path is easy.
Right.
The interview was won or lost on the resilience and Kafka lag questions. That concept of idempotency, it sounds like a nerdy computer science term, but it's actually the cornerstone of trust in a digital economy.
I also love the contractor mindset point. That was brilliant. The idea of, I don't say no, I visualize the risk.
Yes.
That is a golden takeaway for anyone, contractor or not. Leading without authority is all about aligning technical debt with business incentives.
Absolutely. And the AI piece. It's clearly not just a buzzword anymore. In a 2026 interview, if you don't have a strategy for governing AI, the kill switch, the guardrails, you just aren't ready to lead. You can't just turn it loose and hope for the best.
So we have unpacked the architecture, the middleware, the tooling, and the leadership. Expert, if you had to leave our listener with one final provocative thought about this Ecom VIX lead role, what would it be?
I would say this. We are seeing a fundamental shift in what coding even means at that level.
How so?
Throughout that entire interview, we talked about Conductor managing workflows, Constructor managing search, AI generating tests. The role of the lead is shifting from chief code writer to chief system orchestrator.
That's a great phrase.
You're managing a team where half the code is written by machines or managed by SaaS platforms. The real question is, are you ready to be the conductor of that orchestra, where you might not know how to play every single instrument, but you know exactly when they are out of tune?
That is a fascinating place to leave it. From writing code to orchestrating intelligence. Thank you for sitting in the third chair with us today. Hopefully this deep dive gave you the blueprint you need, whether you are interviewing for the job or hiring for it. We will see you on the next deep dive.
Take care.